Hello, Warhawks. This is Mr. Tipton. Today we're going to be talking about Chapter 1.3, talking about measuring line segments. Line segments have a beginning and an end, or two endpoints is a way to think about it. They can actually be measured. Where lines can't be measured, segments can be measured. So let's go ahead and jump into this and look at how we can measure a segment. So sometimes we're going to have them like this, where the length of a segment is just the distance between the 2 points. So as we look at this figure here, this is a number line. So we can see that 0 is represented right here. If we go forward, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then backwards from 0 would be -1, -2, -3, -4, -5, -6. So if we want to find the length of these line segments down here, we've got AB, BC, CD, AC, AD, and BD, and also CD. So if we're going to find the length of these segments, we're just going to count from A to B. That's one way to do it. So be careful when you're counting. Don't start at A and go 1, 2, 3, 4, 5, 6, because that's going to give you the wrong answer. We start at A, and then our first step is 1, then 2, 3, 4, and 5. So the length of AB would be equal to 5. Another way to do that is B is located at 1, A is located at -1, 2, 3, 4. So if we had the difference between -4 and a +1, if we subtracted those, we get -5. But distance is always positive, so it'd be the absolute value of that also would equal 5. But in my opinion, much easier to just count. The length of BC, we'll start at B. We go 1, 2, 3, 4, and 5. So BC also equals 5. CD, we start at C and go to D. So we go 1, 2, 3. That's the length of CD. Go ahead and see if you can figure out the rest of these. I'm going to fill in the answers here. See if you can get them the same. Pause it and fill them out. Okay, there's your answers. Hopefully you paused that and saw if you could figure those out on your own. But AC was 10, AD was 13, BD is 8, and CD is 3. So that's on a number line how we can measure segments. Not too difficult as long as you can count. We look down at the next thing that we'll talk about, which gets into algebra a little bit, is the segment addition postulate. These are any two segments add together to equal a larger segment. So we see two smaller segments here, one labeled AB, the other one BC, and then we see a larger segment here, AC, or you could even think about it as AB plus BC, does equal AC. That's essentially what the segment addition postulate is saying, that these two smaller segments will add together to equal the larger segment, AC, the whole thing. So that's important to remember. As we look down at this next example, here I can see that we have two line segments, EF and FG, and then the third line segment, EG, which is the whole thing. Since we know that these two smaller segments will add up to equal the larger segment, we can actually set up an equation where EF plus FG is going to equal the whole thing, which is EG. So think about what we can do here is we can substitute values. I know what EF is. EF is 8x minus 14. Plus, I know what FG is. FG is 4x plus 1. And I also know what EG is. It's 59. So I substituted all those values here, and I can see that we can set up this equation to solve. Anytime you have a variable, if you set up an equation, you can solve that problem. So the first thing we want to do is look at combining our like terms. Over here we have things that are like. We have 8 and we have 4, and they both have an x with them, making them like terms. So we can add 8x and 4x to equal 12x. Now if we look carefully here, we also have another set of like terms, which would be -14 and +1. So we add those together and 1 equals 15, because it's -14 plus 1, that's 1 more than -14, which is -13. And that's going to equal 59. Now that we've combined our like terms, we can go ahead and try to solve for x. So here's a -13. How do I get rid of a -13? And really I should think about this as -13 would be a better way to say, as instead of plus negative 13. So how would I get rid of a minus 13? I'm going to add 13 to both sides of the equal sign. That's why I like to draw a bar right there so that we can see the difference between the two sides. This is now effectively eliminated, leaving us with 12x. And then on this side, we have 59 plus 13 is 72. The only thing left to do now is divide by 12. Punch it into your calculator. 72 divided by 12 equals 6. So that was part of our answer. We wanted to find x. Now that we found x, we can go ahead and plug x back into this equation where 8 times 6 is 48 minus 14 is going to give us 30. 4 is the length of EF. And for FG, I plug in 6. 4 times 6 is 24 plus 1 is 25. So there's FG, would be 25. Now let's see if those add up to indeed equal 59. Yes, 34 plus 25 does equal 59. So I feel strongly after checking my work that I got that correct. The next thing we'll talk about is a special type of a line segment or point on a line segment, which is the midpoint. The midpoint is the exact same distance from both endpoints. You're going to see another thing here, which is called congruency marks. These congruency marks show us that that segment is equal to that segment, which would make B the midpoint. So there's two things they can do. They can tell you B is the midpoint, and then that means those two segments are equal. Or they can show you congruency marks, and that means that B is the midpoint. Those work inverse with each other. So now, using the segment addition postulate, we know that AB plus BC equals AC, but I don't know the length of AC. But I do know two things that equal each other here. In this particular situation, AB is equal to BC. I know that because of the congruency marks. So I put my equal sign and I set up my equation. All equations must have an equal sign if we're going to solve for x. And I know that AB equals BC. So I can go ahead and I can substitute those values for AB and BC. AB was 6x minus 7. And that's equal to BC, which was 5x plus 1. So there's no combining like terms here. I just put the line down my equal sign. And I go ahead and get my x's on the same side. Now you have some choices here. I like to move the smaller x's because eventually we're going to have to get x on one side. A lot of kids want to move 5x over here and put 11x. But really when we move something from one side, we're actually removing it. So if I want to move 5x's over here, I have to subtract 5x's from both sides so it stays balanced. That's gone. All I'm left with is 1. Over here, 6 minus 5 is also 1, but that's going to be 1x minus 7. To get rid of the minus 7, I add 7 to both sides, effectively giving me 1x equals 8, which is then just x equals 8. I could plug this back in and make sure that they're the same. 6 times 8 is 48 minus 7 gives me 41. That's the length of AB. I want these two things to be equal to each other. I plug 8 back in here. 5 times 8 is 40, plus 1 is also 41. So there we see that AB and BC do indeed equal one another. I hope you enjoyed this. We'll see you in class tomorrow.